Hey, everyone, again, this is the continuation of Java programming. Okay, so I've got to jump on to 82329. Yeah, that's the page I'm looking for. So what we're required to do is to sum the major diagonal in a matrix. Okay, so write a method that sums all the numbers in the major diagonal in an n by n matrix of double values using the following header. Okay, so write a test program that reads a 4x4 matrix and displays the sum of all its elements on the major diagonal. Okay, so here's what I already did, you guys. Created a class. It has only 2 methods. Okay, however, I haven't, as you can see, I haven't done anything on either of them. Okay, so first things first, I believe in jumping straight to the core of the problem rather than bothering myself much about the main method. Okay, so let's get on to it. Again, I'm not concerned much about efficiency here, you guys. Okay, I'm just, as long as it works in the end, that's what I'm concerned about. Okay, so I'm gonna have this method basically takes a 2-dimensional array. So I'm gonna have a variable called sum to hold the sum of numbers in the major diagonal, of course. So I'll simply go is I less than m dot length I plus plus. Okay, so guys, I am repeating this part. This is an inefficient way of doing things. Okay, I'm doing it on purpose. Okay, J is gonna be M. Basically, this part here, not hash code. That wasn't on purpose. You know what? Let me finish up and then I'll explain it in a moment. Okay. You see, this is the length for the ith row. This is the number of elements in the ith row. Okay. However, since this is a square matrix, this number will be the same for I equals to any number less than m. Okay, for all values of i's basically. Okay, so here's what I'll do. Again, guys, this is an inefficient way of doing things. So if I is equals to j, then I simply go sum is equals to m at ij. Okay, well, what I will then do is to return sum. I'll simply return what? Sum. Okay, now that we're through with that, let me jump onto my main method. Oops, it's kinda windy out here, you guys. These are just papers that I use in order to reference. Oops, really? Okay. What do I wanna do? I wanna create. Oh, first things first, let me create this matrix. It's called matrix double 4 by 4. System.out.print enter a 4 by 4 matrix row by row. First things first, I wanna fill matrix. Once I'm done doing that, int row equals 0 is row less than 4 is row less than matrix dot length row plus plus column equals to 0 is column less than matrix dot length. Again, this is a square matrix, you guys. There's absolutely no need for us to do this. We usually do this if you're working with ragged arrays, okay, or something like this. We don't necessarily need to do it. Why? Because we know the number of columns is exactly the same as the number of rows. Display some system.out.print it's gonna be printf though. Okay, so some of the elements in a main in the measure diagonal is %1.1 f. Then I go to the next line. Then I'll go. Now it is time to invoke this method here. Matrix Seems like we threw you guys. Let me just hit the run button and see what do we get. Again, it doesn't matter, you guys, whether you your inputs, you just put numbers in one line or you do them row by row. It doesn't make any difference. Okay. However, it seems like in this case we've got to make sure that we do put them row by row so that it's gonna be clear for us. 1, 2, 3, 4. So that it's gonna be, oh damn, you know what, let me just type a number by number. Let me copy that row. But then as you can see, we're getting the right answer, which is 34.5. Row number 1, row number 2, row number 3, row number 4, boom. Seems like we could, you guys. Let's try something as simple as 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So what is the sum of the numbers? Oh, perhaps let me just go 1, 2, 1, 5. So it's gonna be 5 plus 1, which is 6, plus 2, which is 8, plus 1, 9. Okay, that's gonna be it for this tutorial, you guys. I'm gonna have to wrap it up now. So this was the core of this exercise. Okay, so I'll see you guys in the next one. Cheers, I'm gone.